Okay, let's see. Hold on. Okay, so let's look at this. Question 3, diagram 3.1 shows the stalagmite and limestone in water. Okay. Okay. Rainwater falls and the cavern seeps through the limestone and water with carbon dioxide. Take the solubility. Okay, so this one, right? By now, you need to memorize who is soluble, who is insoluble. So all carbonates insoluble, except for potassium carbonate, sodium carbonate, and ammonium carbonate. Only these three are soluble. Everybody else is insoluble. Okay? Solubility is insoluble. All right? When rainwater falls on the cavern, it seeps through the limestone. Water and carbon dioxide react to form calcium bicarbonate. Okay, is it balanced? 3, 4, 5, 6. 6. Two hydrogen, two hydrogen. One calcium, one calcium. Yeah, everybody is balanced. Okay. Calculate the mass of calcium bicarbonate if 0.5 mole of limestone. So if this one is 0.5 mole, this one also 0.5. So you take 0.5 multiply whatever molar mass is this lah. Calcium is 40, hydrogen, carbon, oxygen times 2. Okay? 48 plus 12 plus 1 times 2 plus 40. 162, correct? Did you get 162 equals to 81 grams. Don't forget your unit. Okay? Recording. Okay, done? Okay. Okay. Solid P, yellow when hot, white when cold is zinc oxide. The other one is lead oxide. When it's hot, it's brown. When it's cold, it's yellow. There's only two things that got color difference when it's hot and cold. One is zinc oxide, one is lead oxide. Okay? So you heat this up, a colorless gas. Colorless gas means it's a carbonate. So this one has to be zinc carbonate. Huh? Colorless, so there's no reaction that releases hydrogen. What you see, there is only two kinds of reaction. You heat up zinc carbonate, it forms zinc oxide and carbon dioxide. You heat up zinc nitrate, you get zinc oxide, but you get nitrogen dioxide and oxygen. Nitrogen dioxide got color, it's brown color. Oxygen is colorless. So if there's only one color gas, it's carbon dioxide, definitely. If there's two gases, then it's a nitrate. Can you see the difference? So nitrate also got gas, but the color got color. So if it's brown gas, it's nitrogen dioxide. Nitrogen dioxide will be released with again together with the oxygen, and that is a nitrate ion. Can I understand? Okay. So if it's a carbonate, zinc carbonate plus nitric acid, you get zinc nitrate. Carbon dioxide and water. Okay? Can I? So what is formula of gas Y, CO2? How you test for gas Y? I think I told you this last week already. Okay, so here is salt P, heat, then it goes inside lime water. Solubility of solid Q. Who is Q? Zinc oxide. Zinc oxide is insoluble. How do you know oxide is soluble or not? Only group 1 and group 2, some of them are soluble oxides because they are alkali metals and earth alkali metals. R is zinc nitrate. Okay, can you understand? Can I? Okay. That day, we did this question already. We did this question already, right? Did we do this? Section C. Not yet. Okay. Can you please do this one? This and this. You write down in your exercise book or your paper the answer because there's no way you can fit it in here. Okay? Can? Just try. So, a pie chart that contains the percentage of ions in seawater. So just two salts that are present. Okay, this one you don't know how to do, also can sit down and try. Uh, yeah, so you just make the positive and the negative combine together. Any two. Okay? Describe a test to verify one anion present in the salt. So who you want to let's say you want to do chloride. So remember, always add hydrochloric acid and then add silver nitrate. And if you see a white precipitate chloride ion present, or you want to test for sulfate. So you write your own words, okay? You want to test for the presence of sulfate, you add hydrochloric acid, and then you add barium chloride solution. And then you will see white precipitate. This white precipitate is barium sulfate. This white precipitate is silver chloride because silver chloride and barium sulfate are insoluble. Okay? Depends on your teacher. I would say okay, but I would prefer you don't write. If you're wrong, write wrongly. Yeah. Okay. These three are all soluble salts. Obviously, you add sodium carbonate it becomes copper carbonate lah. And then if you add acid W, it will become a copper salt again. Alright? Uh, by choosing one of the three salts in diagram 6.2, one or three salts, to prepare copper carbonate, describe a laboratory experiment. Oh, okay. So let's say we do copper chloride plus sodium carbonate. We get copper carbonate and sodium chloride. You don't need to write the equation now. I'm writing the equation so that you know what's going on. Okay, so it's aqueous. This is a precipitation reaction, solid and then aqueous. You all know that? Because this is insoluble. If you don't know that this is insoluble, there's nothing you can do. This is insoluble, so the method you use is precipitation reaction. Precipitation reaction is you take a soluble salt plus a soluble salt becomes an insoluble salt. Okay? Can? Okay, now, so what you do first is you have to have this copper chloride in the aqueous form and you pour into sodium carbonate, which is also an aqueous form. And then what do? Immediately you will have a white precipitate, right? You fill this white precipitate, sorry, not white precipitate, green precipitate will be a copper carbonate. Then you filter. Who do you want, residue or filtrate? Residue. Then you wash and dry. Correct, right? Yeah. Okay, so how do you write it in words? That is the exciting part. Okay, so in a beaker, mix a aqueous solution of sodium carbonate with an aqueous solution of copper to chloride and stir with a glass rod. Then filter the mixture. Copper to carbonate is the residue. Okay? Get wash the residue with distilled water and dry between filter paper. Okay? That's it. Okay? Then you understand? Really understand? Okay. Not that. Okay, it's okay. Okay? Now, the second one suggests acid W. Okay, so basically, now you have copper carbonate. If you react with hydrochloric acid, then you get copper chloride lah. If you react with nitric acid, then you get copper nitrate. If you react with sulfuric acid, you get copper sulfate. See what you want to do lah. Understand or not? So let's say, the question says, suggest acid W to prepare any one of the copper salts. Describe a laboratory experiment to prepare this salt. Okay, so let's say I say acid W is sulfuric acid. Okay, so what do I do is I take sulfuric acid, aqueous, and copper carbonate must be in excess. Remember that? Copper carbonate must be in excess. And then you filter. Who do you want this time? Or down? Down. Down is called the filtrate. The filtrate is copper sulfate, copper sulfate. And then what do you do? Heat until saturated. Cool to get crystals. Dry crystals between filter paper. You write all of that, you get it. Do they ask you to write equation? No. So nice one. Usually they will ask write equation. I don't know why this one they didn't ask. Okay, can? Yeah, but actually not that long one. Okay, so in a beaker, fill, let's say 25 centimeter cube of sulfuric acid. Oh, okay. First you say acid W is sulfuric acid. Okay. Acid W is your furic is different spelling, sorry. Acid. Okay. 0.1 mole per decimeter cube. Okay. Add excess copper to carbonate. How do you know it's excess? Add until copper to carbonate does not dissolve. That's how you know it's excess. Okay, this is to neutralize all the acid. Then you filter this mixture. The filtrate is copper to sulfate solution. Heat the CuSO form in a beaker until saturated. Cool the saturated solution so that crystals form. Filter again to obtain crystals. Dry crystals between with the paper. You can wash a little bit with distilled water if you want. You get it? So carbonic acid, carbonic acid is acid from HCO3 to negative. So it's H2CO3. So it's diprotic. So these two terbalik. So wrong. Hydrochloric acid, monoprotic, diprotic, correct. Phosphoric acid is H3PO4. So it's 3, so no. Nitric acid is mono, but phosphorus is 3. Okay. True about all bases. React with acids, dissolve in water, contain hydroxide ion. No, why not? A base can be insoluble, what? Okay? All bases must be able to neutralize acid. That's the definition of base. Okay? Not that it can form hydroxide ion. Form hydroxide ion is alkali. Alkali can form hydroxide ion. Okay? Base is can react with acid. Okay. Base can react with acid lah, correct lah. Base can react with acid lah. Hydroxide means an alkali, a base that is soluble in water. Okay? Hydrogen chloride is a molecule. When can it have an acidic property? When it ionizes in water to form hydrogen ion. All acids must be dissolved in water. Okay? Uh, Ammonia can show alkaline because it forms hydroxide ion. This is the equation. Aiyah, so dumb. Yeah. NH3 plus H2O hydroxide. Okay. This one we did before, right? Negative log concentration of hydrogen ions is 0.3. What is the molarity of hydrochloric acid with a pH? You just terbalikkan the negative log lah. Okay. Anti-log, right? Okay. What is the pOH value of hydroxide ions that contain? Because if you do negative log concentration of hydroxide ions, it is pOH. That means the concentration of OH ions. If you want to change it to pH, you just take 14 minus the pOH, then you get pH. Okay, so what's the value of this? 1. Okay, so it has a pH of 13, 12.3. Okay, can you understand? All right. Are you guys uh okay with this chapter, or you still want to do next week, or you want to go next another chapter?